Hi guys, sorry that I can't be there today, but I'll try and go through it on here. So we're going to look at half lines today. So we can see here we've got the argument of z minus z1 is equal to theta. So remember that z is just your general complex number, which is going to be in the form of x plus yi. And then z1 will be a specified complex number, and we base it on the argument of this line created here, because remember it's the distance basically between z and z1. We want the line that creates to give us an argument of theta. So as I said, the argument created by the half line, z minus z1, which is the general complex number minus the fixed point, is equal to theta. So we want to sketch that the argument of z is pi over 6 and then find its Cartesian equation. So pi over 6, if we think about our radians, what would that look like in degrees? So we can picture things in degrees a bit easier. Well, pi over 6 is 30 degrees. And we know for argument it's positive, it's going from the real axis, and we go anti-clockwise. Now I'm going to draw a little dot here, and it'll make sense why I do that little dot in a minute. But that will be an argument there of pi over 6. So that's what it would look like. It's basically, so z minus z1 is going to be that line there, and that is going to give us pi over 6. So the reason I've done that little dot there is because basically we're saying, where could z be? It can't be on the origin, because that wouldn't give us an argument, because we wouldn't have a line there. We have to have a line, so basically z and z1 have to be different from each other. And if we think about what we're being told here, the argument of z, so we're basically saying the argument of z minus z1 here. Well, what is z1 in this circumstance? Well, z1 is just 0, x, 0, I, if we think about it, because that's the same thing. So arg of z is the same thing as saying the argument of z minus 0 plus 0i. If you think about it, so therefore z1 is just 0 plus 0i. So basically where z1 is, you're going to draw a circle around that, because z and z1 can't be the same thing. So z can't equal z1, or else you're not going to have a line. I don't know why I put a dot on it. It's not a line, so therefore you can't have an argument, and you can't have a line there. And basically that line can continue off here, but it is a half line, because basically pi over 6 only comes to here. That line is pi over 6. There we go. That line there is pi over 6. But if that line were to continue onwards here, so while it's the same line, that wouldn't give me an argument of pi over 6 anymore, would it? That would be down here, and that would give me a negative argument. And I'm not going to calculate this, but that's not what the argument is. So the argument only go up to basically where the x-axis is. So it's a line I've drawn, so it's a half line. It's not going to go all the way down like I just showed you there. So we sketched it, but we now need to find its Cartesian equation. And there are multiple ways you can go about this. So what we could do here is, we know the argument of z minus z1, well, z, we know, is just a general complex number in the form x plus yi. And if we consider that triangle then, so I just do this. So this bit is x and this bit is y. Well, how can I write those things all in one form? Well, I can use trigonometry, can't I? And I can say that tan of pi over 6 is O over A. So tan of pi over 6 is x over y, isn't it? Sorry, y over x even. Y over x. So tan of pi over 6, if you evaluate what that is, I believe that is going to be, just give me a moment. that's going to be 1 over root 3. So that is 1 over root 3 is equal to y over x. So then just multiply the x across, we end up with y is equal to x over root 3. So that is one way in which you can do that question. So another way which you can do this, you can think about the gradient of that line. So if we just give that line a length there of 1, so we can say that we know the angle's pi over 6, it's got a length of 1. So what we can do there is we can say, well, the gradient of that line is the change in y over the change in x, isn't it? So 1 is equal to, so y, if we just think about the height of y for now, well, if we use right angle trig there, we can say this, sorry. Well, it's the opposite, isn't it? Y is the opposite. So what we could do here is we could say, well, sine of pi over 6 is equal to O, which is y over 1. So therefore, y is basically equal to sine pi over 6. So the change in y is sine pi over 6. That is meant to be a pi symbol. It's just a very bad one. And then same with cos and the x. We can say, well, cos is the adjacent. So we can say, well, cos pi over 6 is equal to the adjacent, which is x, over 1. So therefore, x is also cos of pi over 6. So we can say this, like so, and that will be the gradient of your line, and that will give you tan of pi over 6, won't it? That will give me tan of pi over 6. And then once we have the gradient of the line, well, we know it doesn't have a y-intercept, it just goes through 0. So if that's my gradient, then it's just going to be pi over 6. Oh, so I don't know why I've written 1 there. That's not the gradient, is it? The gradient's 1. I don't know why I wrote 1 there. The gradient's m. Sorry about that. I don't know why I did that. The gradient is m. So sorry if that confused you. So just to clarify what I've done there. So I just made the hypotenuse of that 1. And then I did the trigonometry to get what y and x was in terms of pi over 6. And then what I'm doing there now, so the gradient of that line is 1. So therefore, I'm just going to write it down here. So tan pi over 6, we know is just 1 over root 3, which is what we got before. And then if you think about the equation of that line, so what I can say there now is y is equal to mx plus c. We don't have a plus c, so it's just going to be y is equal to 1 over root 3x. So that's another way of doing it, the method in blue, where we just look at the gradient of that line. But if you would prefer to think of it like we did here, then I'm perfectly happy with that. So the sketch here isn't too bad, and then it's just thinking about, well, z, there is x plus yi, and then just looking at that triangle and saying, well, there we go, we know that tan pi over 6 is y over x, because that's just trigonometry, and then you can rearrange that. Right, we'll have a look at another example now. So we want to sketch the argument of this thing now is equal to 3 pi over 4. So when we think about the argument of that, so remember, that's our definition, arg of z minus z1 is theta. So I would always start with that, because it's important that we can define what z1 is. So let's just put here that the argument of z minus z1 is theta. So I'm just going to rewrite that in that format. So the argument of z, and it's going to be minus 3 minus 2i is equal to 3 pi over 4. So z1 here is minus 3 minus 2i. And now it doesn't say sketch it, but when you're doing these, it is far easier to sketch it. So let's just find where minus 3 minus 2i would be. Well, minus 3 is going to probably be about here. And then minus 2i is probably going to be about here. So, they are our points. I'm trying to write a 2. So, we know that's where Z1 is. Z1 is going to be at this intersection here. I'm going to draw a circle again, because remember that Z can't be equal to Z1. And then it equals 3 pi over 4. So how we actually sketch that is a bit funny, because we normally sketch it from the origin, but we are now sketching it from Z1 this time. So to sketch that, what we are going to do is we're basically going to imagine sort of there's a horizontal line here, and then sketch our argument from there. So 3 pi over 4, that is going to be 135 degrees. So it's going to be an obtuse angle. So it's probably going to look something like this, isn't it? So there's my angle there. And that would be my argument of 3 pi over 4. So that's a sketch of what it's going to look like. So I know we're used to seeing arguments from the origin, but at this point we are basically saying the argument of the line created by Z minus Z1. So remember, Z is the locus we're drawing. So Z is anywhere on that line, on that red line there, apart from we've drawn the circle, because we know it can't be in exactly the same position as Z1. It doesn't work. So we can do it using our equation here. So like we did before, so let's just write it out. So Z is, remember, x plus iy, so we can say x plus iy if we're doing Z minus Z1 here. So I'm rewriting out Z minus Z1 as a line, so it's x plus yi, and then I can just do the plus 3 plus 2i here, because it's a minus minus, which is a plus. So we end up here with x plus 3 as the real part, and we end up with 2 plus y as the imaginary part there. So we end up with this thing here, and then you can consider what that triangle is going to look like. So if we just do this, so if we have a look at this, so x plus 3 is the horizontal, so x plus 3 would go here, and then is it y plus 2 would go here. Y plus 2 would go here. Like so. And obviously when we do the angle here, we could consider what is that going to look like, because when we think about our tan graph, 3 pi over 4, what would that be equivalent to? So that angle there would be basically minus pi over 4. And the reason for that is, I'll just show you actually, I'll just pop it up now. So if I show you this, so this is the graph, if I just show you what tan looks like. So we know tan is the tangent of our circle, so I'm just trying to fill it in, maybe if I go a bit slower, like so. So tan pi over 4, so that's what, tan of 45. So tan, when we go from obtuse to acute, the sign changes. Tan 45 is 1, not just above 1, it is 1. And let's do tan of 135. I'm going a bit too far, aren't I? Tan of 135 is minus 1. So can you see the values? So when we're looking at when the values add to 180 like that and looking at that triangle, if the difference, so the difference is they add to 180, it's just going to be negative that. So pi over 4, tan of pi over 4 is 1. So tan of minus pi over 4 is minus 1, which is equal to tan of 3 pi over 4. So the sign just changes. So if we're looking at the acute obtuse angle, so if I just pull it back up. So coming back here, so 3 pi over 4 is basically going to give me the same thing. So tan of 3 pi over 4 will give me the same thing as tan of minus pi over 4. They will give me the same value just because of how the tan graph works. It's going to be when when the angle is obtuse, then it's the negative version of the acute angle. So vice versa. If tan 3 pi over 4 is positive, tan pi over 4 it'll be the negative version of that. So we can use that to help us, or you can just use 3 pi over 4 if you want to. It doesn't really matter. They'll get you the same thing regardless. You can try that out. So let's just do what we did before with our triangle. So we have the opposite and the adjacent here. So we can say now that the opposite is, either tan 3 pi over 4, or if you like to think of it with the triangle, you can do minus pi over 4. So there's tan of 3 pi over 4, or you can think of it as tan of minus pi over 4 if you're feeling that like that. That'll be equal to the opposite over the adjacent. So the opposite is y plus 2, and the adjacent is x plus 3. So y plus 2 over x plus 3. So then you just need to evaluate what tan 3 pi over 4 is, or what tan of minus pi over 4 is. And we know from before that's minus 1, isn't it? From when we looked at that graph, we know that they're both just going to be minus 1. So they are both equal to minus 1. So however way you want to think about it, if you just want to say the argument is 3 pi over 4, so just make the angle 3 pi over 4. But if you like the triangle bit, you can make it minus pi over 4. It doesn't really matter. And then we just rearrange that, don't we? So either one of these, they're the same. So just multiply the x plus 3 across. So you get y is equal to minus x minus 3. And then we can just rearrange that, can't we? So y is equal to minus x, and then minus the 2. We get minus x minus 5. Now, we're almost done there. It's just we need to consider that this is a half line. This is a half line, and we need to consider the regions where that half line exists. So we basically need to restrict what x and y can be, because if we think about it, I'm going to change my pen colour. Let's make it purple. Yeah. So this bit of my line, because remember, y is equal to x minus 5 would just continue on like this. It would just go like so, where that purple line is. I'll get rid of this to make it a bit easier for you to see. So that line's going to continue down here, but remember, it's only this bit of the line that I'm interested in. So I need to basically restrict what x and y are going to be. So x can only be values which are less than minus 3. So x, therefore, has to be less than minus 3. And then y, if we think about it, y has to be greater than minus 2. Because that line, where it is in purple, that bit just doesn't exist. Because we need to think about where Z1 is. Z1 is at minus 3, minus 2. So, to finish that off, you just need to write your limits there. So we just need to write that x is less than minus 3. X is less than minus 3. And y is greater than minus 2. So this is why, even though it didn't ask you to sketch a diagram, I think it's a lot easier to picture what's going on there. Another method you could do is, like before, we can consider what that triangle looks like. So in using the gradient again, so the gradient of that, well, if it's tan pi over 4, we know it's a 45-degree angle there. So if it's tan of pi over 4, that's a 45-degree angle. So that's going to have a gradient of 1, because basically what we're saying is when you've got tan of 45 and it gets you 1, you're basically saying y and x are the same thing. Because tan 45 is equal to y over x. And if tan 45 is 1, we're basically saying y and x are the same thing. So that's got a gradient. Well, it's actually negative 1, isn't it? Because it's negative pi. It's negative 45. Or 3 pi over 4, it's negative 45. So its gradient is minus 1. So, but that means obviously that still y and x are the same, it's just one is positive and one is negative. So we can use that same idea now, and we can say, well, that means the gradient of that line is -1. So the gradient of that line is -1, and then we know a coordinate on that line. Well, we know the coordinate there is -3, -2. So now we can just put that into our equation. So you do x minus x1, so x plus 3. Sorry, it's y minus y1, isn't it? Apologies. I don't know how to do straight lines, apparently. So y minus y1, so that'll be y plus 2 is equal to m lots of x minus x1, so that'll be x plus 3. And hope you can see we're going to end up with the same thing here. So we end up with y is equal to minus x and minus 3 plus take away the 2, it gives us that minus x minus 5 again. So you could consider it like that as well. You could also consider, without having to do all that, you could also consider, well, where would this line hit the y-axis? What would my y-intercept be here? And you could think about it that way and think, well, have a y-intercept of -5 here. That's what we're saying. That value there is -5. I know our half line doesn't go there, but that would give you the general equation of the line. And like before, you still have to restrict it and say, well, x has to be smaller than -3 and y has to be greater than -2. So that's how we do that one. And then let's think about what would happen here. So now this time the argument is -3 pi over 4. So let's think about what that would mean. So I'm going to use the same sketch and everything because the only difference here is what the argument is now. So it's still going to be, we're still going to have our coordinates here at -2 and 3. Just pretend that's a 2. So still going to have my coordinate here. But then let's think about what the argument would be, what that would look like. We know for negative arguments, it goes, for a negative argument, we go this way around underneath the axis. That would give us, that's meant to be a minus. That would give us a negative argument. So that bit there would give us the negative argument. So we need to consider what that would look like. So this time, the argument is going to be down here. That's going to be my argument. Well, actually, it's not, is it? Because it's -3 pi over 4. So it would actually be there, wouldn't it? Because it's about 135 degrees. So that would give me an argument of -3 pi over 4 down here. And then, so that's what it would look like. And we can sort of see, if we go back up here, it's basically a mirror image in that line of x is -2, isn't it? It's going down this way instead. And you can use the same method that we did before there. So we start out with our, well, z we know is x plus iy. We know that z1, oh, zooming in, didn't need to do that. Z1 is -3 minus 2i. So therefore, when we did our z minus z1, we ended up with x plus 3, and then we ended up with plus y plus 2i. And then thinking about our triangle, so again, you could, if you wanted to, you could do this sketch. I remember that that bit now is just pi over 4. That would just be pi over 4. But either way, it's going to get you the same answer regardless. So we know that this bit here is going to be, that bit there is y plus 2. Whoops. Y plus 2. And this bit here is x plus 3. So now we can say, like we did before with the triangle, we can say that tan, I'm just going to use -3 pi over 4. Tan -3 pi over 4 is equal to the opposite, which is y, the adjacent, which is x. So that will give me y plus 2 over x plus 3. So when I do that, tan minus 3 pi over 4 is the same as tan of pi over 4, which is 1. So that whole thing will just equal 1 now. So then just multiply that across, so we end up with y plus 2 is equal to x minus 3, sorry, x plus 3. And then minus the 2, we end up with y is equal to x plus a 1. Y is equal to x plus 1, which I think makes sense because we've got a positive gradient. If we have a look at this line here, it'd be a positive gradient. And hopefully, yeah, if we continue it along, yeah, it probably would hit the y-axis there at 1. And remember just to restrict the x and y values. So I've used my purple pen before, so let's go back to blue. So here, let's think about, so x has to still be, so x still has to be less than minus 3. But this time for y, let's think about it. Y is going down this way, isn't it? So y has to be less than minus 2 now. So our restrictions there, so x is less than negative 3 and y is less than negative 2. So remember, you do need those restrictions as well. But it all comes down to basically trigonometry. And if you can get your head around this thing here, play around with, if you want to actually play around with your calculators and see the values and see if you can pick up on sort of the, not symmetry, but the reflection there, where it's positive and negative. But yeah, so that is all the things we need to go through there. So you've got those questions to have a look at, exercise 2E question 10. So I'll load this so you can have a look at it, and then you've got your solutions at the bottom of the page.